Yeah.
Good morning, everyone. My talk today is on the accelerated real-time 3D MRI thermometry using a retraced spiral Untitled Chapter. So real-time MRI thermometry is a key aspect of MRI strategy focused also on procedure for vision monitoring, especially the brain region where the location and the temperature change is vital. And monitoring the entire insulated volume is important because of two possible reasons. First, the focal spot might shift perpendicular to the TV slice that you intend to monitor. And the second is we may need to monitor more than one slices at the same time for the entire radiation profile. Then the advantage of 3D MRI thermometry is better with the advantage that it has large coverage and higher SNR compared with the 2D sequences. However, the challenge is the acquisition time to cover the entire 3D case space. The method we are using in this study is the 3D retraced spiral in-out trajectory. And for 3D case space, we have to cover the in-plane and the through-plane, or KX, KY, and KZ. And for in-plane, we are using the spiral case space sampling pattern, which is an efficient and motion-insensitive trajectory that covers the case space using a spiral pattern. And here we revise the traditional spiral out pattern with a retraced spiral in out to cover the case space twice to reduce blurring and improve SNR. And on through plane, we use stack of spirals by stacking the spirals along the KZ direction. So the first figure is the readout gradient. We have symmetric gradients before and after TE, and it results the resulting trajectory in the KX-KY plane is the case space moves out first with a pre-winder and then spirals into the center at TE and then spiral out to the edge of the case space. And after rotating 180 degrees, it will repeat itself so that it can reduce blurring and also with the 2 times average. And on the KZ, it's just a stack of such spirals. However, even with the efficient trajectory, we're still facing the challenge when we do the fully sampled case space, which is a reduced temporal resolution. And because in the thermometry, the temporal information is usually redundant, so this information can be taken advantage of to reconstruct the image based on undersampled case space data. And there are many models for this reconstruction method, and one model we were using here is called Kalman filter. The first equation shows the evolution of images, and the second is acquisition matrix. And the temporal information here we are relying on is that the adjacent frames are similar except for around the focal spot, so that the case space data needed for accurate reconstruction can be reduced. And here we acquire half of the slice encoding and leading to 2-time acceleration. We performed the experiment on the GE 3T scanner on an Insight Tech transducer, and the imaging is implemented on the RT-Hawk platform with online reconstruction to enable real-time sequence control and monitoring. And we use GRE sequence with flip angle 5 to 10, and the TR is 22, and TE is at 12.8 to have enough temperature encoding. And the field of view is 280 by 280 by 36, and 36 is along the slice direction. And the resolution is 1.5 times 1.5 times 3. And it includes 24 spiral in-out interleaves and 12 encoding steps, and 6 with the 2-time undersampling. And the temporal resolution is 3.15 seconds per frame. And here shows the result for the experiment, and we show the temperature map of all 12 slices. And from this figure, we can show that we can see that the temperature rise can be seen in 3 slices, which correspond to 9 millimeters along the direction. And we compare the common filter, and a naive reconstruction with undersampled method is to combine the data from different frames, but the disadvantage of this method, it will tend to underestimate the peak temperature because it averages the several frames. And from a retrospective study, we see that. And on the right, we perform a prospective study using the common filter, shows a pretty sharp temperature rise and at the focal spot and 9 hottest spots around that. So in conclusion, real-time 3D thermometry using retraced spiral in-out trajectory with acceleration along the slice encoding direction can achieve a high spatial and temporal resolution. And the accuracy of reconstruction using common filter on undersample data is improved. However, in the next step, we'll perform more animal and patient experiment to further validate this method. And thank you.
Are there questions from the audience? If I have one while we're waiting for a second. So you've shown the advantages. What are the challenges that it faces? Spiral needs very good gradients, and I'm thinking of the water. What are the challenges that you really face?
Yeah, spiral is very sensitive to off-resonance and eddy currents, all that, and this is even more challenging with the water bath. So we have to tune the center frequency and shimming very carefully, and in a lot of cases, when the shimming is off, it can suffer a lot. But we propose the spiral in-out retraced, which is a little bit better than the traditional spiral out.
All right, thank you very much. Let's
All right,
move on to the